So now we have what we call the inverse logarithmic properties. So let's say you have log base b of b to the x. And I'll write it this way. And we don't know what that equals. Well, you could write it in exponential form. You'd say b to the power of a equals b to the x. All right, well, by the same logic we used in the last video, if the bases are the same and they're equal to each other, then those exponents have to be equal to each other. So a equals x. Now you could think about these different situations, but remember there are certain restrictions on b. b has to be greater than 0 and b cannot equal 1. Okay, so that kind of takes care of the restrictions. So when we say a equals x, then that means log base b of b to the x just equals x. So if you're taking the logarithm of it, but then you're going to raise it to the exponent, then it's just going to equal x, because a logarithmic function and exponential function, if they have the same base, they're going to undo each other. This property is used a lot. This one gets a star. You want to make yourself a list of these properties. Remember, there's going to be like 8 of them. So we've done 2 in the first video, and now we've done this one. But this one is a very popular property. Okay, so now we're going to do this other inverse property. It kind of works the other way. This is in exponential form. Okay, so let's say that you have log b to the power of log b of x, and that equals something, we don't know what, say a. Well, then if I were to write it in logarithmic form, I would start with log, and then what would be the base? The base would be b, the argument would be a, and it equals all of that exponent. Log base b of x. I'll use the parentheses. Well, similarly, if these two things are going to be equal to each other and the bases are the same, and you know that b has to be greater than 0, in fact the argument has to be greater than 0 also, well then a has to equal x. So what does that mean? It means that this whole thing that we started with, that has to be x. So if you take the exponent function and then you take the logarithm and then the exponent, it's going to just equal x because they're going to undo each other because again the bases are the same, so we can say that. Okay, so you have to have that matching up of the bases, but that's how the inverse properties work. I don't usually see this one as much when we use stuff, but it's a great property. Okay.